In this video, and probably the next video, we're going to be looking at normal distributions. And we're going to compute some probabilities on these distributions. But first, let's look at what a normal distribution is. A normal distribution is a set of data that if you graph it, will have this type of curve. Symmetric curve around this vertical line here at 0. And then these values that we have between these vertical lines, we can think of those as probabilities, percents, or area under the curve. So the total area under this curve is 1 or 100%. Total probability is 1, or we can think of that as also 100%. And we can also think of it as percents. So in other words, this one right here represents a value on this set of data that is 1 standard deviation above the mean. This one right here, where the 2 is a value that is 2 standard deviations above the mean. Over here we have the 3, and then the negatives imply that the value is below the mean. So 0 corresponds to the mean or the average. So -1 corresponds to a value of 1 standard deviation below the mean. -2, this corresponds to a value 2 standard deviations below the mean. And the -3 corresponds to a value that is 3 standard deviations below the mean. So just a little quick reference here when we talk about probability. P of x is greater than or equal to 0, less than or equal to 1. So that means the probability is always between 0 and 1, including 0 or including the 1. Okay, so when we say that a certain event has a probability of 0, that means it cannot happen. If we say a certain event occurring, the probability of a certain event occurring is 1, that means it's certain to occur. So now, this formula right here is used to determine these values here that we have on the baseline of this horizontal line. So this says here, in this case, the x represents a value in the distribution. X bar represents the mean, okay? And S will represent the standard deviation. The standard deviation, of course, is the extent to which data values deviate or variate from the mean. So if you have a standard deviation of 15, that means that each value is approximately, on the average, a distance of 15 units from the mean. Okay, so in this example, I'm going to say that the mean, which is denoted by x bar, is 100. The standard deviation is 15. So if I take a data value and subtract the mean and then divide it by the standard deviation, it tells me how far that data value is from the mean in terms of standard deviations. If this comes out to be a positive number, then the z-value is above the mean. If it comes out to be negative, then it's below the mean. So for example, in this case, let's suppose, okay, so again, the 0 represents the mean. In this case, it would represent 100. So let me do it this way. So this would be 100 right here, okay? If I started from scratch, this would be 100. Okay, so the standard deviation is 15. Then I go 15 units this way, that would give me 115. Okay, so we're 1 standard deviation above the mean. If I go 2 deviations above, then this would come out to 130. Another 15, this would be 145. Okay, Now below the mean, I go 15 the other way. So this would give me then 85. And then go 15 more to the left. This will give me 70. And then go 15 more. This will give me 55 over here. And I can keep going, but notice that as soon as I get past this, either 3 deviations or above or below the mean, I don't have much area or probability left over here. Okay, so we start off with these actual values in the distribution, and then using this formula right here to get the z-value, I simply subtract the mean, which is 100, and divide by the standard deviation. So 100 minus 100 is 0, divided by 15 is 0. Okay, and then 115 subtract 100 is 15, divided by 15 is 1. 130 minus 100 is 30, divided by 15 is 2. That's why I'm getting these values, the z-values. 145 minus 100 is 45, divided by 15 is 3, and then do the same thing over here. Now on this side, notice 85 minus 100 is negative 15, divided by 15 is negative 1. Okay, and then 70 minus 100 is negative 30, divided by 15 is negative 2. And then 55 minus 100 is 45, divided by 15 is 55 minus 100 is negative 45, divided by 15 is a negative 3. That's how we get these values. So we're subtracting 100 and dividing by the standard deviation. So now let me clear this. And then of course it'll give us these values right here. Okay. So I could say then, if I want to look at probability, so let's suppose that in this case, this is data from an IQ test. Suppose we administer an IQ test to 1,000 people, and we converted some of the z-values to, or some of the actual scores to z-values, and we got this. And right here at the center is the mean. So this 0 corresponds to the 100. Okay, and when we do this kind of setup, this is called a standard. And I have it over here. Standard normal curve. So in a standard normal curve, once I make this transformation, if I were to recalculate, the standard deviation would come out to 1. Standard deviation would be 1. The mean would be 0. And then again, these are percents of items in a particular interval, or we can convert these to probabilities. Usually in probabilities, we write this as 0.3413 or just 0.34 if we round off. So again, what happens if I wanted to find, say, the area between, say, this z-value and the mean? So going from here to here. So let's say I wanted the probability here. Then I would have to get the z-value. I'd have to use this, subtract the mean, divide by the standard deviation, and I would get some decimal over here. It'd be positive because it would be above the mean. And then I could either use a table or a calculator to compute the probability or the percent of scores that fall in this interval, or just the area under the curve. So again, these values over here represent area under this curve. They represent probability. They represent percent of scores. So percent of scores, area under the curve, or probability. So if I said, again, suppose we have an IQ test, and we have a mean of 100 on the test, a standard deviation of 15, and I were to say, what is the probability that if I pick one score of some person at random, that that person scored between within one standard deviation of the mean? In other words, suppose I take one score at random, what's the probability that that person scores in this range right here between these two? Because it's just one standard deviation this way, one standard deviation this way. Okay, so all I would have to do is add these up, and I would say the probability, the percent of the person being in that interval would be 0.68 if I rounded out to two places. The probability would be 0.68. Would be 0.68. Okay, so now if I clear this, and these percentages are given here, what's the probability that if I pick one score at random, that that score would fall within two standard deviations within the mean? Okay, so that means it would be this right here, from -2 to 2. Okay, so if you add those up, you get 0.94 or 95.44%, or probability would be 0.9544 or 0.95 rounded out to two places. Okay, what's the probability that a randomly selected person score from that distribution, that that person scores within 3 standard deviations? So from -3 to 3, that would be all this area, all this probability, and you can see it's 99.72. 99.72. Okay. Now, if you're talking about an intelligence test, IQ test, values between -1 and -1 or within one standard deviation of the mean are considered average. Okay. Notice, what is the probability? What is the probability based on this distribution, this curve here, that a person scores a score higher than 145? Okay. But notice, the 0, remember, corresponds to 100. So 15 more, that's 115. 15 more is 130. 15 more is 145. So the probability the person scores higher than 145 on the test, which would be a genius, okay, that would be a genius, is 0.13. Or actually converted 0.003. So it would be, I have to convert that to it without the percent. That would be 0.003. So that would be a genius. So these are opposites. So the bright people would score over here on this side of the curve, and the not so bright would score on the far left. So in other words, what's the probability that a person has an IQ of less than 55? Average is really right in here. Okay, between these two values, between 85 here and 115. That's considered average. Okay, a person that scores less than 55 has some issues, and that would be again 0.00. This is like one here, 1.3. Okay. So let's clear this. So now you can work problems. Sometimes these are not going to be whole numbers. These are going to be decimals over here. So in order to solve a problem like this, you'd have to use a calculator, or you'd have to use a table. Okay. So let me show you this. So let's suppose I wanted to work the problem. Without using this diagram here, without using a table. Then I would go to the calculator and I would hit second, and I would hit this right here, distribution. And I would have to use this one right here, this function right here, normal CDF. Okay, cumulative distribution. So I hit number 2. Okay, now again, to use the calculator, it makes it a lot easier if you have it in terms of a standard curve, okay, where we're using z-values. Okay, so again, I'm going to work the same problem, but without referencing this, using the calculator. So this supposed to say again, what's the probability that a person scores within 1 standard deviation from the mean? So obviously we already know the answer, but if I do it in the calculator, it would be like this. So it'd be from -1 to 1. So again, we're using the standard normal curve. So it'd be -1. That would be the lower bound. Okay, we have the left bound. And then the upper bound to the right, that would be +1. So that would be 1. And the mean for the standard normal curve would be 0. So put this at 0. And if you're dealing with something like this, where you have the z-values, the standard deviation is always 1. Okay, even though it might be, but because I have it transformed here, I use 1. So I put 1 there, and then I lower this to paste it. Okay, so this is going to give me the sum of these. Okay, hit enter. Okay, so there it is. If you're looking for a percent, it's 68.27%. But using probabilities, we would write it without the percent, so it's 0.68. Okay, which is what we got here. That's right there. Okay, 0.6827, depending on how you want to round it off. There it is. Okay, now how would I do it if I don't have the format this way? I don't have the standard score in this format. Then I could again go second and distribution over here and hit number 2. Okay, so let's say I wanted to find out what is the probability that a person scores on this IQ test between 85 and 115. 85 and 115. Okay. So now I don't have it as a z-value, and sometimes they'll give it to you that way. So in this case, for the lower bound, I would write 85. For the upper bound, it's 115, so it'd be 115. Okay, so now here I'm using the actual values, not the z-values, so the mean in this case would be 100. That's this mu here. I used X bar for the mean, the symbol for the mean. You can also use mu, which looks like a U. So it's 100. And the standard deviation, again, is what I said it was, okay? If you're using the standard format, this will always be 1, okay? But in my case, it's going to be 15. And then what the calculator does, it does that same setup. It uses a formula for the z-value and computes it out. So now everything is there, so go down and paste it, hit enter. Okay, and then hit enter again. And see, we got the same answer without using the standard normal distribution. Like I said, if you don't use the calculator or you don't convert your actual values that you're working with to z-scores or z-values, then you would have to use a table. Okay. Okay, so this gives you the foundation, and then I'll come back on another video and show you some more examples using the calculator. Thanks for watching. We'll see you next time.